Hello friends. Imagine you are driving, a collision happens, the airbags deploy, and you are dazed. Who calls for help? Who makes the car safe for the firefighters about to cut open the door? Here is the surprising answer. The car does it itself. In this video, we are going to trace exactly how that works. Tesla published a reminder of this in April 2026, and it is a perfect window into the software engineering behind every connected vehicle. 4 things happen automatically after a serious crash. The hazard lights strobe faster, an emergency call goes out, the high-voltage battery disconnects, and the dashcam locks the evidence. That is not magic. That is a carefully designed software pipeline. Let us start by understanding how the app and the car talk to each other in the first place. Alright, so how does tapping a button on your phone actually unlock a car sitting in a parking garage? It takes 3 hops. First, the Tesla app on your phone packages the command and sends it over HTTPS to Tesla's Fleet API, a cloud service Tesla launched officially in 2023. That request carries an OAuth 2.0 authentication token, basically a signed digital pass, that proves the command is really from you. Second, the Fleet API routes the command down to your specific vehicle over a persistent cellular connection the car always keeps open. The protocol under the hood uses MQTT, a lightweight messaging standard, built for devices that need to stay always on without draining resources. Third, the car executes, then sends an acknowledgement back. The whole round trip takes under 2 seconds. That always-on cellular link is also what makes the crash automation we are about to explore possible. Now look at this. Once that communication channel is established, the Tesla app becomes a genuine remote control. You can lock or unlock the car, start climate preconditioning so it is already cool before you get in, toggle Sentry mode which streams live encrypted camera footage directly to your phone, close windows you left open, and push a navigation destination so it is ready before you even sit down. Each of these is a distinct call to the Fleet API, authenticated with your token, and delivered to the vehicle over that cellular link. The Sentry Mode live camera stream requires premium connectivity and app version 4.5, 5.6 or later, because the end-to-end encryption needs the newer handshake the updated app supports. Every one of these features relies on the same pipeline we just traced, and that pipeline is also what lets Tesla deliver entirely new capabilities to your car without you visiting a dealer, which brings us to the Spring 2026 update. Here is the interesting part. You can see exactly this pipeline in action right now. Tesla's Spring 2026 software update, which began rolling out with version 2026.14 in April and continues with 2026.20 and the latest 2026.20.3 build from mid-June, delivered 3 meaningful safety upgrades wirelessly. First, blind spot warning accent lights. On newer models with interior LED strips, the cabin lights flash red on the relevant side when an object enters your blind spot while driving or when something approaches your door while parked. Second, encrypted dashcam clips. As of 2026.20.3, every clip saved to your USB drive is encrypted, and only your vehicle can decrypt it, protecting the footage as legal evidence. Third, auto-install OTA so updates apply overnight while the car is parked. No dealer visit, no scheduling. The car simply woke up smarter. Now let us trace what happens when the car detects something far more serious than a cyclist in a blind spot. Alright, let us trace the event-driven pipeline that fires the moment a serious crash occurs. Step 1. The airbag deployment, or a severe collision detection event, triggers a software interrupt inside the vehicle's onboard systems. Step 2. Hazard lights immediately begin a faster strobe pattern, and the eCall system activates. Depending on the region and hardware, the car either uses a built-in eCall module or a paired phone to contact emergency services, transmitting the GPS location, vehicle type, VIN, and number of occupants to a public safety answering point, even if the driver cannot speak. Step 3. The high-voltage battery is automatically isolated. An onboard contactor opens, disconnecting the battery from the drive and power systems so the chassis is electrically safe for first responders. Step 4. Dashcam footage, now up to 24 hours and encrypted since 2026.20, is preserved as evidence. 4 automated steps, none requiring the driver to act. So here is the big picture. A Tesla is not just a car with an app bolted on. It is a software system on wheels, connected to the cloud every 10 seconds, able to receive new instructions overnight. When a crash happens, an event-driven pipeline takes over instantly, sending help, protecting the battery, and locking the evidence, all before a human can react. And when engineers discover a better way to handle a crash scenario, they push an OTA update, and it reaches every compatible car on the road, not just the next one off the assembly line. That is the power of the feedback loop. Anonymized real-world crash data flows back to engineers, who refine the response and send the improvement back out to millions of vehicles. The Spring 2026 updates we covered today, the accent lights, the encrypted dashcam, the auto install, are exactly this loop in action. Thanks for watching. See you in the next one.